In this video, I'm going to walk through some solutions to some lecture practice problems. Hopefully you've already given these a try. If not, pause this video and try each of these questions on your own first, and then continue watching as I walk through my solutions. All right, our first one's about liquid nitrogen, which is really cold nitrogen. It boils at 77 Kelvin, and it's used to make ice cream, which is what is so fun about it. So what if we wanted to convert that temperature of 77 Kelvin into degrees Fahrenheit to have a little bit better sense of how cold it really is? Um, so first what I would do is we have Kelvin. I would make a plan. We know Kelvin, so we should probably convert into degrees Celsius, and then we can use an equation to convert into degrees Fahrenheit. So my 77, and I'm going to make sure that I report all of my, use all of the digits here. I have 3.000 Kelvin minus 273, and I'm going to use my 0.15 version of this, will give me my degrees Celsius. Now, I'm going to note that this 273.15 is part of a conversion, so this is an exact number. And my 77.000 is a measurement, so this will be inexact. So it's the one that I care about the significant figures on. And I have 5 significant figures, and I have 3 decimal places. I'm doing a subtraction step, so I am going to care about the number of decimal places rather than the total number of significant figures. And I'm going to report my answer then in terms of decimal places. So I'll do the same number of decimal places, 3. So when I plug this into my calculator, I get a value that is negative 196.150 degrees Celsius. And I have 3 decimal places. So I'll be reporting this to the correct number of significant figures. And you'll notice I've gained a significant figure, right? Instead of 5, I now have 6 significant figures. And this happens a lot with addition and subtraction. You can gain or lose significant figures as long as you're keeping the least decimal places of your inexact numbers that have significant figures. All right, partway there. I made it to degrees Celsius, now to Fahrenheit. So I'm going to go ahead and plug this into an equation. So my temperature for Fahrenheit is going to equal 1.8 times my negative 196.150 degrees Celsius plus 32. Now I only have one inexact number here again. Here, I'll highlight it. So here's my inexact number in my first step, and now that number that I get from my calculation is still inexact. It still has a number of significant figures. That 1.8 and that 32 are part of the definition of how to convert Fahrenheit and Celsius. So they're exact numbers in this case. So I'm going to do this in 2 steps. I'm going to first do my multiplication step and then my addition step following the correct order of operations. And so I'm going to get a value from my first one that is going to need to be 6 significant figures because I have 6 significant figures in my inexact number. So I'm going to get a value that is negative 353.070. That's 6 significant figures. And now it's going to be plus 32. And then when I add my 32, now I'm going to be looking at decimal places. And so the important piece here is going to be my 3 decimal places because I'm doing addition. And so when I add that, I'm going to get a value that is negative 321.070. I still have 3 decimal places at the end, so I have the correct number of significant figures. So thinking about what temperature liquid nitrogen is boiling at in Fahrenheit, it's negative 321.070 degrees Fahrenheit. All right, now let's move on to the next problem. Reporting the temperature here in our picture that we have. And so each of these markings is 0.1 degrees Celsius, and I'm starting at 24, and this goes to 25. I'm going to come here to the top and kind of bring this over in between the markings and see where I'm looking. So if each of these marks is 0.1, then the closest markings I have are 24.3 and then 24.4. And the temperature is somewhere in between these two. So that's my job to use my eyes and estimate it. And you might get a different number than me, and that's okay because there's a lot of uncertainty in me just estimating something I don't have a marking to compare it to. So I'm gonna go ahead and I'm gonna estimate that this is, I know it's at least 24.3 because it's above the 24.3 marking. And I don't think it's quite halfway. I think it's kind of a third of the way. So I'm going to say 3. And so this is my estimated digit right here, this last 3. And you might have done a different one. But I would argue that if you did 24.39, you would be estimating incorrectly. But a 0.32, a 0.35, these are all fine. And this really represents 4 significant figures when I'm reporting this. All right, last one. Which of the following numbers represents the most confident measurement? Well, let's go through and let's determine how many significant figures are in each. So in my first value, I'm ignoring my preceding zeros because they are placeholders. So I'm going to start looking at my non-zero numbers and then after that. And there's a decimal, so that 0 that follows will have will be significant. So this is 1, 2, 3, 4, 5 significant figures. All right, moving on to the second number, I have trailing zeros and no decimal place. So those trailing zeros are a placeholder. So I really only have 2 significant figures in this mile measurement. All right, last one. I have a 3 that's non-zero and a 1 and a 0 in between. That makes the 0 significant. So I have 3 significant figures. So now I know the number of sig figs I have in each measurement. So when thinking about which one is the most confident instrument measurement, it's the one that has the most that produces the most significant figure digits. And so that's going to be this first number right here, the 0.0044580 meters. So this one is our most confident measurement because we have the most significant figures that can be reported.